Okay, so this week we're going to start looking at some different parameters that we test. So far, everything we've made a claim about has been about a single mean, the weight of a bag of potato chips, the number of acres that the average farm consists of. So, all these tests have been about a single mean. Those are not the only parameters that we test. Okay, so we're going to today look a little bit further and look at some other parameters that we might test. If you're following along with me, this is Chapter 5, Part 1 in our studio. So here are the types of parameters that we might be thinking about. Okay, so before we get into that, first thing we have to recall is that a parameter is a number that describes some aspect of a population. It does not depend on chance. We usually don't know what it is. We can collect some samples and get some statistics that might serve as evidence for a particular proposed parameter or evidence against that. It can be known, statistics we can calculate, those come from the samples that we take, okay, and it will depend upon the sample. And that, of course, does depend on chance because the sample that we get hopefully is random. If it's not random, we probably have some reason to doubt the data that we might get there. There may be some bias involved in that. So we often use a statistic or a point estimate, okay, for a parameter. So we've seen this already. If we're thinking about population mu, okay, sometimes we have a sample mean X bar. A lot of you last week emailing me, I don't know what's mu and I don't know what X bar is. Mu is what's proposed for the entire population. X bar is what you got from your sample, okay? So they do signify a difference. They're both a mean, but they're different kinds of means, okay? For standard deviation, population, we have the symbol sigma, okay? If that came from a sample, though, we would just call that lowercase s. Remember, up until now, we have been assuming that we know sigma, even though we said that's not really realistic, because if we don't know mu, then we could not know sigma, okay? And we're always making our guesses about mu. Up until now, we've been assuming we know it. And if you recall, I told you we would have to fix that later. Okay, we're going to kind of get into that soon. We also can talk about a population median. We can have the median of a sample. We can talk about the third quartile of a population, the third quartile of a sample. What we usually hope, okay, through randomness and selection of a sample, is that when we get one of these point estimates from a sample, that it's pretty close to what we would really get for that parameter in the whole population. That's why we want to choose random samples that are representative of the true population, okay, so that there is no bias, that we make these match up as well as we possibly can, okay? So over the next couple of days, we're going to be talking about the basic 5 parameters. Up until now, this one is the only one we've tested any claims about, okay? One mean, a single mu. We're going to be looking at some other parameters we can test. The mean of a difference, the difference of two means, a single proportion. Remember, that's a percentage of something. The difference of two proportions. Okay, when we test these, remember we will do that using evidence we gather from samples of the same parameter. Okay, so a sample mean of differences. Instead of mu and mu diff, that's how that's read, mu and mu diff, we would have X bar and X bar diff. Instead of difference of two means, mu1 minus mu2, we would have difference of two sample means, X bar 1 minus X bar 2. One proportion P, one sample proportion P hat. Difference in two proportions, P1 minus P2. Difference in two sample proportions, P hat 1 minus P hat 2. Okay, so we're going to look at means. That's kind of where we've been hanging out in our last sort of few days. So we're going to focus on the first 3 of these in Chapter 5, so that's all about means. The others are going to come in Chapter 6. Okay, Chapter 6 is where we'll start talking about proportions. The good thing about that is once we get to proportions, a lot of this procedure for testing you will be a little bit more comfortable with. So we should be moderately comfortable with the mean of a single population by this point. As we've noticed, we use the symbol mu to represent a population mean. Okay, so this is what we've been doing up until now. Research questions like this. Is the mean height of students at UC Davis more than 66 inches? We have a single mean of one population that we're looking at. Okay, students at UC Davis, the single mean we're looking at is the mean height. The question suggests, remember, two hypotheses. So what are they? We've got a null and we've got an alternative. So let's look at this. Remember, a null always has to be an equation. An alternative always has to be an inequality. And since we see the words more than, we see that this statement is really addressing the alternative. Okay, so I should be able to create the null, mu equals 66, and the alternative, mu is greater than 66. Okay. Now, what about if we were looking at mean difference of paired data? Okay. Sometimes we need to take two numerical observations from the same set of individuals for our sample data. Okay. Then our parameter, what we're interested in is the mean difference of these observations for the entire population. And we write this, we call this mu diff. Okay. That's our parameter. The statistics would be X bar diff. So how do I know when I'm working with a situation where my parameter now, instead of being mu, is mu diff? Let's look at this example. Which events do University of Kentucky students attend more often? Movies or sporting events? Okay, think about how you would collect this information. You would be getting two pieces of numerical information from one group of students. You would be asking the same group of students, how many movies have you seen? Then you would ask them how many sporting events they've attended to. And we would be looking to compute the number of movies minus the number of sporting events. It doesn't really matter whether we do movies minus sporting or sporting minus movie. That's arbitrary. As long as we stayed consistent through any kind of a test we were doing, that wouldn't matter. Okay? But what makes this mu diff? What am I interested in? I'm interested in which one the same group of people did more. I didn't ask one group of students how many movies they've seen and then go find a different group and ask them how many sporting events. That wouldn't tell me very much. Okay? I need to know both pieces of information from the same group of students, and that's a mu diff situation. Okay, so our parameter there is mu diff. That's the mean difference between the number of movies and the number of sporting events seen in the last year for all UK students. And then if we wanted to know that, we would take a sample of UK students. We would ask them the number of movies, ask them the number of sports, do the subtraction, and find the mean of that difference, and that would be our X bar diff. Okay, hopefully it would look very much like mu diff for the entire population of UK students. Okay, what about writing hypotheses? Typically, but not always, we're checking to see if there is a difference or not a difference between the two observations. Okay, think about the logical claims when we ask ourselves, have they seen more? Okay, is mu diff equal to 0 or not? In such cases, our null hypothesis will always be mu diff equals 0. Okay, the null will assume there is no difference between those two things. Okay, the only question you really have to assume or think about then is whether or not the alternative is one-sided or two-sided. Okay, this time the question asks which one of these types of functions students have attended more. Notice that it does not propose one of these events is more popular. Okay, the prompt didn't tell us that it thought they saw more movies or thought they saw more sporting events. It just asked, is one of the two more popular? And that kind of led us to think that this should be a two-sided test. Is this difference positive or negative? Would there be more movies or more sporting events? That we didn't really make a claim about in our description. So because it doesn't lead us to believe one is greater than the other, that's why we're using the two-sided not equal to alternative here. Okay. What about the difference between two means? Remember that mu diff and x bar diff was the mean of differences, okay? This is the difference between two means. They sound alike, but they're not the same. This is the third situation we could encounter when we collect numerical data from two independent populations. Okay, in this case, there's a mean for each population. We've got like a group 1 and a group 2. So we have mu1, which is the mean of group 1, and we have mu2, which is the mean of group 2. Okay, so let's think about an example. Remember in the mu diff scenario, we got two pieces of information from the same group. We were interested in the difference in them. Okay, for one person, we wanted to know both movies and sporting events, and we were interested if there was a difference there. This situation is a little bit different. Okay, this research question says, are male college students at UC Davis less than 3 inches taller on average than females there? Okay, so here we've got two individual populations. We've got women and we've got men. Okay, so we'll let men be population 1 and then think about what our parameters are. Mu1 is going to be the mean height of male students at UC Davis, and mu2 is going to be the mean height of female students at UC Davis. What we're really interested in is the difference in those two populations. Okay, mu1 minus mu2. Now, why is it not the mean difference here? Because I'm getting one height from the males and one height from the females, and I'm comparing those pieces of information. Each group only got asked one question, whereas in the other example, in the UK students example, each person got asked two questions, and we looked at the difference between them. Okay, so that's kind of one way to differentiate. What about our hypotheses? Our question deals with an inequality again. Okay, so that means it's talking to us about the alternative. If we're checking to see if the difference is less than 3, okay, that was the language included in our prompt. I know my null has to be an equation. I also know that the comparison number over here has to be the same. Okay, so my null is going to be mu1 minus mu2 equals 3. My alternative, mu1 minus mu2, is less than 3.